Alright, this is the second tutorial, and we are continuing from where we stopped. Kind to the journey. Remember to click on subscribe to subscribe to my channel. So we are saying that we have this example and we are trying to find the decision boundary. Of course, the focus of support vector machine is to find decision boundary between two sets of data. So in this case, we have two sets of data, A and B, D, E. So where A and B are the positive and D and E are the negative class of data. So this is what we are going to be using today. For example, take note that this is the margin. I have support vectors A, B, and D. Alright, so from this place, take note what the margin is. Also take note the margin width. In this case, the margin width is what? 2 minus 1. I'm going to write it with a pen. Margin width is 1, and it came from this place, 2 minus 1. So that is how we got the margin width to be 1. Then in this example, take note of we have 4 training points, A, B, D, E, 2 classes, positive and negative, and then we have 3 support vectors. So each time you want to solve a problem, try to outline all these important parameters before you continue. How then do we figure out what the decision boundary will be? That is the question that we always continue to ask. Once we get the answer to this question, then we have understood support vector machine. How do we figure out what decision boundary will be? There are steps we have to take. So just like I mentioned that you should use a pen and a paper, now it comes, you need to write down the steps, and as we mentioned the steps, we are going to be taking these steps one after the other. So what we are going to do in summary is that we are going to find the values of parameters W, B, and alpha. So these are the values that we are going to determine. If we are able to determine the values of these, then we have actually found the decision boundary. The reason is because these values determine the equation for the decision boundary. A line is defined by equation function of x is equal to mx plus c. So how to find the line is to simply find the equation for the line. So we are trying to determine the equation for the decision boundary. And to do that, we need to find the values of these parameters, W, B, and A. So what is W, B, and A? That is what you might ask. Parameter W is a normal vector which is perpendicular to the boundary. Always remember that anytime we are talking about support vector, we assume one point, an unknown point in space, and it's a vector that points towards the boundary in the positive direction, and we have the offset to be B. So this is an assumption you always make. This is the first assumption you'll need to make, and that is how to solve first assumption. So remember, this is the first thing you always assume. There exists the parameter W, which is a vector. It's a vector because we don't know the dimension of the data. It can be 2 dimension, it can be 3. So we assume a vector pointing in one direction. How then? Okay, there is another thing I did not mention. Maybe alpha. What does alpha mean? I'm going to mention that in a minute. So let's start with W and B for now. How do we find W and B? That is the question. So let's display the example we are using to work and determine how to find W and B. Step 1 is to draw the boundary line. So for given data, we first draw the boundary line, and I've drawn the boundary line, which is a line crossing through x is equal to 1.5. Step 2 is write the equation for the line. How do you write equation for a line? For a horizontal line, we have the equation to be, sorry, for a vertical line, the equation is x is equal to a. So there is equation for a vertical line. For this example, we have a vertical line and x is equal to a, where a is equal to the intercept on the x-axis. So take note of this: for any vertical line at all in geometry, the equation is x is equal to a. If you are given any problem and there's a vertical line, the equation is x is equal to a. Intercept on x-axis, as you can see, it is 1.5. So what would be the equation for this line? The equation for this line is x is equal to 1.5. Step 3 is that we need to rewrite this equation to be of the form wx plus b equals 0. Always take note that this equation is an equation for support vector machine. So memorize it. You always have to write it a lot. It may be written in another form, but ultimately this is the equation for support vector machine, or the equation for the decision boundary. So we see how we can work with this equation to find the value of w and b. So let's try this equation this way. It's the same thing. And we are trying to write the equation of the line x is equal to 1.5 to be of the form wx or w dot x plus b equals 0. Meanwhile, this is our equation 1, and this is written in this way. So anytime you have system of linear equation, let's say ax1 plus bx2, let's say minus c equal to 0, it can be written in the same way as a, b, x1, x2, then you have minus c equal to 0. So that is exactly what we've written here. So in this case, we are writing this equation in this form. So we have the same as x minus 1.5 equal to 0, right? Good. So how did we get here? This equation x is equal to 1.5 is the same as 1x plus 0y minus 1.5 equal to 0. So if we write it to this form, we have 1, 0, xy plus, then this is minus 1.5 equal to 0. I'm sure this is clear. So because this equation x is equal to 1.5 is exactly the same as this. So if it's not clear, feel free to pause this video and make sure you understand it. If it's not still clear, leave me a comment in the comment box and be sure I'm going to reach you by Skype and explain this to you very clearly. Alright, so we have step 3 done. Then the next is step 4. Scale the equation such that the margin width is equal to 2 over w. So how do we scale this equation such that the margin width is equal to 2 over w? So I'm going to write this big how. How do we do this? I'm going to stop here and continue in tutorial 3 because I want you to understand each step of the way. So in tutorial 3, we see how we can solve this part 4 that says scale the equation such that the margin width equal to 2 over absolute value for w. I'd like to thank you for viewing. Remember to subscribe if you've not subscribed.